This is Caitlin Hagel, and I'm doing the AP Calculus BC FRQ for the year 2014. So first, part A, find the average rate of change of A of t over the interval 0 to 30, indicate the units of measure. We do A of 30 minus A of 0 over 30 minus 0. And to do that, I plugged it into my calculator, and I have A of 30 and A of 0, so we have 0.7829, etc. minus 6.687 over 30 minus 0, which then would equal negative 0.197 pounds per day, to add the units on from it in the question. And then part B says find the value of A prime of 15. So to do that, A of t is here, and I just plugged it into my calculator because we have calculator access. So the derivative of A of t at 15 would be negative 0.1635. So A prime of 15 equals negative 0.164. And so to interpret that, I would just say that the amount of grass clippings left in the bin is decreasing at a slow rate of 0.164 pounds per day. So I guess I'll write that out. Okay, part C. Find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So to do that, we'd use an integral. So A of t equals, we have to add the average change in there, so 1 over b minus a, so that would make it 1 over 30. Then the integral from a to b would be 0 to 30 of A of t. So then I also plug that, dt. And then I also plug that into my calculator down here. And so if you plug that into your calculator, you would get that t equals 12.415. And that's your answer. Answers. And then finally for part D, the equation that you would use, we're finding the linear approximation to A at t equals 30, and we use 0.5 pounds in remaining in the bin. So the equation to do that would be, or the expression would be, L of t equals A of 30 plus A prime of 30 times t minus 30. And then again, in my calculator, I found that A prime of 30 equals negative 0.055, etc. And the A of 30 equals 0.7829. And then to solve that out, you plug those numbers in and you'll get your value for t. So to do that, we will take 0.5 equal to 0.7829 2928 plus a prime of 30, which extended out would be negative 0.0559776, and then that would be times t minus 30, and then we would distribute that in, and that would get us to 0.5 equal to negative 0.055976 t plus 2.462208. And then if we added this over to the 0.5 and then divided by what's in front of our t value, we would get t equals 35.054. And that would be your answer for the linear approximation. So to sum it up, that 35.054 is the time, because you're using the variable t, at which there will be 0.5 pounds of grass clippings remaining in the bin. Okay, question 2. The graphs of the polar curves r equals 3 and r equals 3 minus 2 sine theta are shown in the figure above for 0 to pi. Okay, A. Let r be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine 2 theta. Find the area of r. So to do that, we are going to use the area formula that begins with, so we have the area, which is equal to, well, first we start with, so this area is, we know, is a quarter of a circle with a radius of 3. So if we do pi r squared, if you plug in 3, it's going to give you 9 pi. It's going to give you 9 pi, and then since this is only a fourth, it's over 4. So we start with 9 pi over 4, and then you add that, and then to find the area of this section, you're going to start with, it's just part of the area formula, 1/2, and then the integral from 0 to pi over 2, because this is pi over 2, and then you're gonna do this, 3 minus 2 sine 2 theta squared d theta, and then I plug that into my calculator here and plug that whole equation in, and I got 9.707. So we'll add that, and that will be our answer. That's the area of r. So 9.70796. That is our area of r. Next question is B. For the curve r equals 3 minus 2 sine 2 theta, find the value of dx d theta at at theta equals pi over 6. Okay, to do that, we're going to start with the expression, equation, whatever that we know, which is x equals r cosine theta, because this expression or equation is going to help us find x, which is needed to find dx d theta, and that's what we're trying to find. So, and we also use this because we know r. So to do that, we do x equals r, which is here, 3 minus 2 sine 2 theta cosine theta, and then to plug that into our calculator, dx, we're going to use this answer, which is dx d theta at theta equals pi over 6, and then we use this expression in our calculator, and to do that we do 3 minus 2 sine 2 theta times cosine theta, which is what we have here, and we find the derivative of this, So this is what we're trying to find the derivative of at theta equals pi over 6. When we did that, we got negative 2.366 as our answer for this value. So that answer is negative 2.3660025, etc. All right, and then for C, we are finding the distance between the two curves for 0 to pi to 2. Oh, sorry. We are not finding the rate at which the distance is changing with respect to theta. So in order to do that, we're going to do outer minus inner. So that would be the distance equals 3, which is the outer, minus 3 minus 2 sine 2 theta. And that's the inner and outer. So that just gives us 2 sine 2 theta. And then to do that, now we need to take the derivative of 2 sine 2 theta. And in order to do that, we do the derivative of the big D, which is the distance, over d theta at theta equals pi over 3, because that's what the question is asking. And then I again put that into my calculator down here and got the derivative of 2 sine 2 theta at x equals pi over 3 is negative 2, if rounded to the nearest third decimal, and that is the distance between the two curves, negative 2. Oops. Okay, and then finally part D, we are going to do, what does the question say? A particle is moving along a curve r equals 3 minus 2 sine 2 theta, so that d theta dt equals 3 for all times. Find the value of dr dt at theta equals pi over 6. And so in order to do that, we need to break down dr dt. So we were doing this because we need to take the derivative with respect to t, and then in order to find dr dt, we need to break this up because we already know d theta dt. So to break this up, we would do dr d theta times d theta dt, and then that would go to, we would keep dr d theta the same, times 3, because we know that d theta dt equals 3 from the question. And now in order to solve for this number, we're going to do the derivative of dr dt at theta equals pi over 6. And again, I did that in my calculator. So 3 minus 2 sine 2 theta at pi over 6, like it asked in the question. And again, that gives us an answer of negative 2. Let it load, so that would be negative 2, but then we also still have this 3 here. So we'd have negative 2 times 3, which equals 6. Or sorry, negative 6, because of the negative here. So our answer for part D is negative 6. Okay, now for question 3, we're starting with part A, find g of 3, and that is almost given to us in this formula. So to do that, we do an integral from negative 3 to 3, which is in our question, of f of t dt. So what this tells us is that we're trying to find the area under the curve from negative 3 to 3, so of this area. And to do that, we're using We're using the triangles are given, so half base times height. So the area of this triangle would be 6, the area of this triangle would be 4, and the area of this triangle would be 1, but it is -1 because it's under the x-axis. So that makes it 6 plus 4 plus -1, which equals 9. So 9 is our value for g of 3. Next question, B. On what open intervals contained in -5 to 4 is the graph of g both increasing and concave down? So, in order to do that, first we know that this is a graph of f, and we also have to make a note that g prime of x equals, or is the same exact thing as f of x. So now that we know that, if we look at the graph, we know, first of all, we know that when g is increasing, g prime is positive. And we also know that when g is concave down, g double prime is negative. So we can find that the graph is increasing on the values from -5 to 2, all right here. We know that the graph is increasing because this part of the graph is positive or above the x-axis. So we know that it's increasing on -5 to 2. And then we also, if we look at where it's concave down, we know because the slope, so to find concave down, we're going to look for where the slope is negative. So this is a negative slope and this is a negative slope. And that is, so concave down on here. So -5 to 3 and 0 to 4. And then if we look where those overlap, we know that the so our final answer would be the graph of g is increasing and concave down on the interval -5 to 3 and 0 to 2, because the graph, again, the g prime of x equals f of x graph is, we know this because it is decreasing for the concave down, because it is decreasing, and then to find the increasing we used the positive side of the graph. So decreasing and positive on those intervals. So that's how we found B. Our next question is C, which we'll do up here. C. The function h is defined by h of x equals g of x over 5x, and we are finding h prime of 3. So in order to do that, we're going to go h of x equals g of x over 5x. And then in order to break this apart, we're going to use the quotient rule. And so I'll just break that apart really quick using the quotient rule. So it's going to be low di minus high d low. And so to do that, we're going to break it apart by, so h prime of x equals 5x over 5x squared. And then to combine that, we are now going to add in, we can combine it in the next step, but the next step would be to plug in 3's for all of our x's. So because we're looking for h prime of 3, so h prime of 3 would then equal, when we plug in all our x's, 5 times 3 g prime of 3 minus g of 3 times 5 all over squared. And then we would just simplify this out, or add in all the like terms. And when we do that, we're gonna get negative 75. I already have this plugged into my calculator, so we get negative 75 over 225, which then would then make h prime of 3 equal to negative 1/3. So our value for h prime of 3 is negative 1/3. And finally, for part D, the function p is defined by p of x equals f x squared minus x, and we are going to find the slope at the point x equals negative 1. And in order to do this, we're going to take p of x equal to f x squared minus x, and then we're going to use the chain rule, break this apart using p prime. We're going to find p prime of x, and the chain rule would make it f prime x inside, and then the derivative of the inside, which would make it 2x minus 1. And then finally, we are going to use this x equals negative 1, and we're going to go p prime of negative 1 equals, when we plug this into here, we are going to get negative 2 times negative 3, which equals 6. So p prime of negative 1 equals 6. And there are our 4 answers. Okay, and now on to question 4, which is a table with train A and train B. Our first question asks us to find the average acceleration, which is simple. We're just gonna take VA of, oh wait, it's asking from 2 to 8, so VA of 8 minus VA of 2 over 8 minus 2, which you can find these values in the table. So we're going to do negative 120 minus 100 over 6, which is equal to 110 over 3. And then the units are minutes. Oh, minutes per, or sorry, meters per minute squared because of acceleration. So this is the average acceleration is negative 110 over 3 meters per minute squared. Our next question is B. And the question asks, does the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with the interval 5 to 8? So because we know that this line is continuous, it says it right here, differentiable. So because this is differentiable, this function is differentiable, we can also state that the train is continuous. So because we can state that this train is continuous and differentiable, we can use the intermediate value theorem. So in doing that, so we know VA equals differentiable, which makes VA equal continuous. And so because we know that, we can use the IVT. And through the IVT theorem, we can state that from going from 40 to negative 120, the train has to pass in a velocity of negative 100 at some point. So, in stating that, because we know that 40 is greater than negative 100, which is greater than negative 120, we know that, so by the intermediate value theorem, we know there is a time in 5,8 that 100. That is our answer for B. For C, we are using, it is asking us to use a trapezoidal sum for the second part, but the first part asks us to write an expression involving an integral that gives the position of the train. So in order to write a position expression, we are going to so it wants it for time t equals 12. So we're going to do the position of equals 12. In order to find that, we know the position SA of 2 plus the integral 2 to 12 VA of t dt, and to solve that, we know that that equals 300 because of this. We know that this right here equals 300 because it's given to us, so that equals 300 plus the integral 2, or sorry, we know this is 300, integral 2 to 12 VA of t dt. So that is our position expression. And then the next part, in order to find this part of the expression, or this part, we are going to use a trapezoidal sum with 3 subintervals from, we're on 2 to 12, so starting at time t equals 2, so we're going to take that off using those 4 subintervals. And in order to do that, we are going to do, so it's integral 2 to 12 VA of t dt equals 3 times, because that's the difference, it's just the basic trapezoidal sum, 100 plus 40 over 2 plus 3 times 40 minus 120 over 2 and plus 4 times negative 120 minus 150 over 2. And all these values were found in this table above. We were using these two in this one, these two in this one, just subtracting them and then multiplying by what's like the difference between these, and then always dividing by 2 in a trapezoidal sum. And so, and when solving that out, that equals negative 450. So if we're going to answer that in sentence form, it's going to be, well, first, sorry, we're going to plug it back into here. So 300 plus, so plug back into the equation. 300 plus negative 450 equals negative 150. So that's our answer. So position, train A is 150 rest because of the negative sign, we know this. West of the station. And that's where we got the negative 150 from. And then for part D, we are, let's read the question. A second train, train B, travels north from origin station. Velocity of train B is given here. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. So in order to do this, we're going to use the the Pythagorean theorem, and we're going to solve it using implicit differentiation. So it's pretty basic math. I'll just solve it quickly. Okay, and then from these questions, we know that 300, we know x equals 300. We know, where did it go? Y equals 400 was given to us somewhere. Oh, right here. So we know x equals 300, y equals 400. And if you plug in z to this, if you plug in those values, we'll get z equals 500. So we can plug that in using this equation. So VB of t equals negative 5t squared plus 60t plus 25. And if we plug in time t equals 2, we will get negative 20 plus 120 plus 25, which then we would use to, so let's go over here. We're going to plug it all back into this equation. So we'd go 500 dz dt, and then we have 300 times 100, which is 30,000. 300 times 100 plus 400 times 125. So then that makes dz dt equal to 80,000 over 500, which equals 160 meters per minute. As your final answer for part D. And there is your work for question number 4. All right, for question number 5, for part A, we're going to find the area of R. To do that, the area, in this case at least, is top minus bottom. So we're going to take the top equation minus the bottom equation. So area equals the integral from 0 to 1 is from 0 to 1. And then we are going to take the top equation, which is x to the x squared minus negative 2x dx, because area is always subtraction. And then we're going to solve this out. So then find the integral of these equals, oops. So 1/2 e to the x squared plus x squared. And then we're going to do it with 0 to 1. And then plug those in. We're going to get 1/2 e plus 1 minus 1/2. And the answer would be e plus 1 over 2 is your area. Okay, on to part B. Write, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 2. So, to find the volume, we always start with pi. In the volume expressions, we always start with pi. And the integral we were using, so 0 to 1 of the, again, top minus bottom. So we're going to go, what's the top one? X e to the x squared. And then to each of them, we're going to add 2 because we're rotating around -2, so we need to add 2. And then also in volume rotations, we always square each piece. All right, and then again subtraction, and then the bottom piece, so -2x, again plus 2 because of this rotation line, and then again squared. So, and dx. So that should look right. And then that's all it is because this we're not supposed to evaluate. And then finally for part C, we are going to write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So in order to do that, we know these 3 lengths. We're trying to find this length. So we need to use y prime. So let's do that. Y prime equals d over dx of the derivative of x e to the x squared, which would end up equaling ex squared 1 plus 2x squared. Okay, and then since that's the length, because we know that's the derivative, we add up these 3 sides, which is root 5, 2, and 1. No, root 5, 2, and e. Okay, so yeah, root 5, 2, and e. So the perimeter would equal root 5 plus 2 plus e, because we're finding the perimeter, so we just add all sides together. We know these, and then we already know this, but we have to take the integral of it. So we add the integral from 0 to 1 of the square root of 1 plus ex squared, parentheses, 1 plus 2x squared dx. And that is your perimeter expression. Okay, this is question number 6 about Taylor series. Reflection. Where R is raised. Okay, find the value of R. So, the first thing we're going to do is find the R, because R is the radius of convergence. And to do that, we're going to use a ratio test. Okay, we start with as n approaches infinity of -1 to the n plus 2, because we have to add 1 times 2 to the n plus 1 times x minus 1 to the n plus 1 all over n plus 1, and then we have to multiply by the reciprocal, so n over -1 to the n plus 1 times 2n, 2n times x minus 1 to the n. And then now we just need to simplify this. So and then to do that, we go -1 times 2 times x minus 1 times n all over n plus 1. And then next we're going to take the limit. So because of the absolute value, we take away the -1. And then we keep the absolute value. So the 2 stays. And then this stays because it's an absolute value. So because of this, because of the equation that we know, and since this value is less than 1, this converges, and therefore we can say that if we divide by 2, x minus 1 is less than 1/2, and so we know that r equals 1/2. All right, and so for a, we found the value of r equals 1/2. And now we're going to find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f, about x equals 1. And the easiest way to do this is to write out the series. Okay, to write it out, it's a summation of infinity n equals 1 of -1 n plus 1 to n over n plus 1 to the n. And then we write this out. So it's 2 x minus 1 to the first power minus 2 to the second power over 2 x minus 1 squared plus 2 cubed over 3 x minus 1 cubed. And then since it's only asking for the first 3 terms, that's as far as we need to go. And now to find these first 2 non-zero terms for f prime, we need to find the derivative. So to do that, f prime of x equals, so the derivative of this would be 2, and then the derivative of this would be 2 squared x minus 1, and then plus 2 cubed x minus 1 cubed, and then plus etc. So in order to simplify this part, we then write plus the function here. So write plus -1 n plus 1 times 2 to the n without this times x minus 1 to the n minus 1, and then etc. So this is the first. Okay, and then it says for about x equals 1, so that tells us that we need to know that f of 1 equals 0, and that'll just be used in the next part. And then Okay. And then to find, okay, so our answer for B would be this general term, and then we can actually simplify this out, so f prime of x equals 2 minus 4x minus 1 plus 8 x minus 1 squared. So that would be the first three non-zero terms. And then this is the general term. Okay. And then we are going to go back to C and look at the Taylor series for f prime about x equals 1. Find part B is a geometric series. Find the function f prime to which the series converges for x minus 1 less than r, and use that function. Okay, to do that, we're going to start with what we have written here. And in order, first we simplify it. So to do that, we start with f prime of x equals 2 over, well, first we kind of look at this. So if we come back up here, getting to here, we'd multiply by negative 2 times x minus 1. And same with here. Negative 2x minus 1. Looking at that, so that is our value that goes down here. So we have 1 minus this value, so negative 2x minus 1. And so using that value, we can actually simplify that. Equals 2 over 2x minus 1, which, and then if we look back up here, or not here, sorry, here, we have this, 1/2, and then now we need to take the integral in order to find the function. So to do that, f of x equals the integral of this, so the integral of 2 over 2x minus 1. And then if you solve that out, that's actually a natural log, so ln of 2x minus 1 plus c. And again, now we're going to bring this down. So we have f of 1 equals 0. So then, in order to do that, so we have this. This means that 0 is equal to the natural log of 2 minus 1. And then, so that would make c equal to 0. So then, we look at f of x, we go to ln 2x minus 1 with x minus 1 less than 1/2, and that would be your answer. And when we found this, we went from ln of 1, which equals 0, and therefore that's how we got that c equals 0. And that is your answer. Question number 6.